5.3 is graphing quadratic equations. So all these things that we've been working on, factoring, quadratic formula, now we're going to learn how to graph them. So we're going to use everything we've learned thus far. So the parent function of a quadratic is just y equals x squared. So that is a parabola that opens up, centered at 0, 0. That means it's a U shape that opens upward. And it should be symmetrical. Okay? Alright, our parent function, our standard form looks like y equals ax squared plus bx plus c. Okay, where c is our y-intercept. Alright, so looking at our graph, we start here with a vertex. Vertex is this point right here. And the vertex always lies on this imaginary line that our parabola is centered around. Okay? And each part of the parabola is the same distance away on each side. We call this the axis of symmetry because it's symmetrical around that line. Remember, vertical lines are x equals just a number. So it'll be x equals whatever number that's going there, which will also be the x value of your vertex. Okay. Your y-intercept is right here. So that's where it crosses the y-axis, just like when we did linear functions. And then these 2 points right here are where they cross the x-axis, so those are x-intercepts. Okay, now we need to look at how we find each one of these things. So to start with, our axis of symmetry is that vertical line that runs in the middle, and we get that by x equals opposite of b over 2a. So it's x equals a number, because it's a vertical line, and this number comes from the a and b in our equation. Okay. Then to find the vertex has the same x value as the axis of symmetry because it lies on that line. So the x value is always negative b over 2a. But then we have to solve to find y. So we're going to plug in x and solve for y. Okay. All right. Then our y-intercept is really fairly easy. Our y-intercept is always on the y-axis, so it's always when x is 0. So it's always going to be 0, comma, c. Whatever the c is right here. That tells us where it crosses the y-axis. Okay, that point also gives us another point because this is our symmetry. So if we have a point 1 away here, we have to have one away on the other side. And we'll use these symmetries to help us graph. Notice that my x-intercept is 2 away here, so it's 2 away on the other side. Okay. Well, let's get rid of those lines for now. Alright, now our x-intercepts. How we get our x-intercepts? If we're lucky, we can get them by factoring. Or if it doesn't factor, we can use quadratic formula. Okay. So either way, those solutions are where it crosses the x-axis. Alright, so let's look at some graphs. Okay. Alright, to start with, we have this point right here is our vertex. So our vertex for this one would be 1, 2, 1, 2, 3. So 2, 3 is that point. Our axis of symmetry is that line that runs through here, so it's x equals whatever that x value is. It's going to be the same as this x value right here. So x equals 2. And then our y-intercept is where it crosses the y-axis. So it crosses right here at -1. So it's going to be 0 because x is 0, and then c, which is -1 in this case. Alright, now looking at the next one. To find the vertex, my vertex is right here where it changes direction. So our vertex in this case is 1, 1, 2, 3. And notice that our vertex can be a maximum, like it is here. That is our max value. The highest it gets before it comes back down. Or here it's a minimum, it's the lowest it gets before it goes back up. So you can have other way depending on if it's open up or open down. Okay. Our axis of symmetry in this case is this line right here, which is x equals, and then whatever the x value is, we know it's 1. And then our y-intercept is where it crosses the y-axis. It's going to be 0, comma, whatever number that is. So this number right here would be 1, 2, 3, 4. So 0, 4. Alright. So now you see if you can label all 3 in this picture right here. And we will check it together next time. When you're ready to move on, we're moving on to steps to graphing a parabola. So how do we graph this thing? First of all, we start by finding the axis of symmetry. So our axis of symmetry, we said, is a line, and it's x equals opposite of b over 2a. So let's look at our equation here. A is whatever's in front of x squared, so a equals 1. B is whatever's in front of x, so b equals 2. And c is whatever's here by itself, so in this case it's -3. Okay, so here we have opposite of b, so -2 over 2 times a is 1. So that's -2 over 2, which I know is -1. So we get x equals -1 as our line. You have to have the x equals because it's a line. It has to have the equation part. So I'm going to come here where x is -1, and I'm going to draw this line. Okay. Next, I need to find the vertex. We know the vertex is going to have this x value because the vertex lies on that line. But we still need to find the y value. So we take this and we plug it into the equation. So I have y equals, everywhere I see an x, in parentheses, I'm going to put my -1, just like we do with function form. Make sure you put the parentheses so that you square the negative. Okay. And that is 1 minus 2 minus 3, so -4. Okay. So -1, 2, 3, 4 is my vertex. So I've got 1 point. Okay, then I have to decide if it has a minimum or a maximum. So that's based on if a is positive or if a is negative. In this case, a was +1. So a is positive, so it has a minimum, so it opens up. That's important information to know because if it opened down, I would know not to look for x-intercepts because it wouldn't cross the x-axis. If it opens up, it's going to cross the x-axis. It's going to cross it twice. Okay? So we can get those x-intercepts or zeros or roots. All those words mean the same thing. We can get our x-intercepts by factoring or using quadratic formula. So let's try factoring first. Okay. So I'm going to put 0 in for y. We have x squared plus 2x minus 3. Okay, this is trident method, so I multiply my ends and get 3, which is 1 and 3. To get 2, knowing that I have different signs, I need positive 3 minus 1. So I have x plus 3, x minus 1, and we don't have to worry about dividing because there was nothing in front of our x squared. Now I have to set both pieces equal to 0 to solve, so I have x plus 3 equals 0 and x minus 1 equals 0. Here I'd subtract 3 and get x equals negative 3. Here I'd add 1 and get x equals 1. Okay, so to write those as ordered pairs, it's going to be negative 3, and then we said y is 0, so comma 0. To be x-intercepts, the y value has to be 0. Okay, so I have negative 3, 0, and 1, 0. And notice this one's 2 away from my axis of symmetry. This one's also 2 away from axis of symmetry. So I'm keeping that symmetrical shape. Now, next is my y-intercept. That one's the easy one. We know it's just 0, comma c. So in this case, that's 0, comma, we said c was negative 3. Okay, so I'm going to go to negative 3. 1, 2, 3. Put a point. Remember that you can mirror it on the other side. So if I have 1, 1 away here, I have 1, 1 away on the other side. Okay. And then we just connect the dots. If for any reason this doesn't give us enough points, so we do all of this, but some of these points end up being the same points, and we don't end up with at least 3 points to graph, then we make a table. So if we need more x values, or more points, make a table. So for example, I could say, okay, what if x was 2? And I could find y, so I go in here and say, okay, 2 squared is 4, plus 2 times 2 would be 4, so 4 plus 4 minus 3, so 8 minus 3 would give me 5. So 2, 5 should be a point. 1, 2, 3, 4, 5, so we didn't do too bad there. And then since that one's 3 away here, there should be 1, 3 away on the other side. So I got a little sloppy on this side. There we go. Alright, so we don't have to make a table if we have 5 values, but if we didn't have enough points, didn't have at least 3 points to graph, then we'd want to make a table to make sure we get the full shape of our graph. Alright, and that's all there is to graphing it. So try this one and we will check it in class. Thanks for watching.